amazing, isn't it?
And then I'll give you the signal when we're good to go. Is that all right?
Yes.
The classes, this here is amazing too, our students. Good evening, everyone. My name is Anna Kore. I am co-director of Energy Futures Lab, and it is my pleasure to welcome you this evening to the Future Energy Festival, a showcase of energy research at the college. It is a very special event for us at the Institute. It has been since 2019 that we have not been able to run this event in person. So we are delighted that so many of you have come out to join us this evening on a cold and wet night in London. We hope you have enjoyed all the activity that you have seen outside this room so far. And for those of you who have not been able to go around the building yet, we hope that you will spend some time joining our colleagues and enjoying the atmosphere that we have here at the college. There is a lot of different things happening in the next few hours. On the ground floor, you would have seen outside, we have stands that are hosted by researchers working in different energy-related fields. They are all extremely proud and excited to be here this evening and would be very happy to talk to you about their work. And we hope that you will make time to speak to them and enjoy their excitement in their research. There are also quite a few exhibits across the hall, and you would have seen that we have a number of lightning talks, which our researchers and academics at the college are delivering this evening. On the door, you will see the program. Those lightning talks will start again at 7:15 when we finish with the lecture. In that room, you will also see the Imperial Zero Pollution team, who are busy trying to help us make our campuses more sustainable at the college. Please go and give them plenty of encouragement and also strain, so they do quite a bit more for us. And on the way into this room, you would have seen we have a small exhibition, which is marking 15 years of the Sustainable Energy Futures MSc course, which is a very special occasion for us for this particular program. When we set it up back in 2007, it was a completely new course. There was nothing like that anywhere around the world. And today we are delighted to have in the audience several of the people who have been key players in instigating the ideas and also delivering this course. It has been 15 years of pleasure and joy for us to see our students do wonderful things after they graduate from this course. And the particular course, of course, has been unique at the start and maybe imitated since then in other places when our colleagues in other institutions realized the importance of the topic. However, we still think that we can be proud at the college that we have a unique MSc course, and this is due to the breadth of topics that we are able to cover at the college, the excellent teaching that we offer in all these different areas, and of course the wonderful partnerships that we are able to secure working with industry around the globe, actually. For those of you who are not familiar with our MSc course, it is an intensive, I should say perhaps a very intensive, for those students in the audience, one-year program, a multidisciplinary program. And our graduates, we hope, are going to be the future leaders in the energy sector. And we give them the opportunity to get a wonderful technical grounding in different energy disciplines. But we also give them training in policy and economics. Of course, they work across a diverse range of industries that you have seen exhibited outside in the stalls. And many of them have also developed their own companies over the years. Now, of course, I don't want you to take my word for it, why it is amazing. And I would like you to take a look at the video that we have prepared, featuring some of the staff and students who have made this program this wonderful opportunity it is. Couple of seconds to get it going. we will restart, obviously.
Clear that one of the missing links were I was the first director of the MSc in Sustainable Energy Futures. Energy at the time was very important. It was already obvious that we needed to work on sustainability, and it was clear that one of the missing links were people capable of viewing energy as a system and understanding enough of the links between the various components to be effective. There was no training, there was no program available, and so decided, well, let's do it our own. Let's do something which is highly distinctive, a bit imaginative, and will put us at the forefront of the field. There was then a very strong support by the college in enabling us to do an experiment, essentially, which require completely different organization, and so they say, okay, let's try it because it's worthwhile. We have very strong support, and I will be forever grateful for let us try to poke the system and do something highly innovative.
Sustainable Energy Futures is a master's program which really empowers students to learn skills in energy and deploy those skills.
The MSc is a great course because it brings together people from all around the world who are passionate about solving today's energy problems.
We are going through a once-in-a-life transition towards renewable energy, zero carbon systems. And this is a very complex issue, require a multidisciplinary knowledge.
What's very cool about the course is it's actually evolved as the energy system in the UK has evolved, or energy systems more broadly, has evolved into more of a complex adaptive system.
The course itself touches on so many topics that it really trains us as generalists, but generalists that know enough about each topic to be dangerous.
All of them arrive at the college fresh and smiling at the beginning of the term. Then during the term I can see the strain and the pressure, but then the smiles come back again at the end of the course, and they understand what they have actually achieved, which is no mean feat to go through this MSc course.
The coursework, I must say that was really taxing. I probably did over 100 hours of sleepless nights. What I am trying to say is the coursework did tune my mind to build resilience, to stop thinking outside the box, and it brought out of me the kind of fresh thinking that is required in solving real-world problems today.
As soon as I started the course, it really opened my eyes. Sustainable transport modules, the very deep technical knowledge that you get in chemical engineering, in process engineering and electrical, but also looking at policy and economics. And all of that grounding that I got on the course, I still use today.
One thing that I really loved about the course was the field trip at the end of the course. So you get to go to those amazing facilities like the fusion reactor, and you get to hang out with your friends, and this is just a really fun and friendly experience overall.
This Masters has been going for 15 years now, and there's this really large cohort of alumni associated with the Sustainable Energy Futures programme.
The alumni network is absolutely integral to this course. So not only will you cover interesting material in the course, but the network that you form is really key.
Every time we ask our alumni to do something to help us out, to be involved with the current programme, they always seem delighted to get involved.
Doing this programme has been pretty instrumental to my career. On this day 5 years ago, I was doing my thesis presentation, and I was approached by someone in the audience who worked for a battery storage company called Renewable, and I think having the SEF course in my credentials was definitely a huge part in me getting another graduate program scheme under my belt with Vattenfall, my current employer.
So I co-founded a company called Cocoa Networks 8 years ago, which is mainstreaming ethanol as a cooking solution and household energy solution in homes in sub-Saharan Africa. The Sustainable Energy Futures Masters was extremely helpful in evaluating and making that choice from the perspective of really understanding where the biggest areas of impact would be.
So still in energy, as you can see, and I think SEF definitely helped me to get there. First, let's face it, it's a well-known degree, and so that's very useful to get a job in energy somewhere else, like I did. Worked in Canada, and the UK, and France, and in the US, and it was very helpful.
The 4 years that I spent directing the Energy Futures Masters were without doubt the 4 most rewarding years of the 18 years that I spent at the college. The reason for that was quite simply the fantastic group of students that I got to work with during that time.
What really stands out for me about the course is just how it brings out the best in everyone. The students come there because they have a mission in life, they really want to make an impact. The staff really like teaching the material because they deeply care about the subject. And we've done this for 15 years now, hopefully another 15 years at least.
There's a lot left to do in energy system decarbonisation. We started out by looking at low carbon electricity systems. The debate has clearly moved on. It's about decarbonising across industry and transport and buildings. That's upped the challenge in all of the technology areas that we educate in, and means this course is still vitally important.
I think we're very proud, and I'm very proud to have been associated with this programme. I think it's been a really important programme. I think it will go from strength to strength. I think the recognition of the need for an interdisciplinary approach is even stronger now than it was 15 years ago. So I would really like to see this programme built out and to educate and train an even larger cohort of students.
Happy birthday, SEF.
Happy birthday, SEF.
Happy birthday, SEF. 15 years.
Happy birthday, SEF.
Happy 15th birthday, Sustainable Energy Future course, and many more to come.
Yeah, indeed. Here's to the next 15 years. And with that, I would like to thank everyone who contributed to this wonderful video, and also to the MSc course, of course, over the last 15 years. And now it is time to move on to our keynote, the keynote lecture this evening, which is to be given by Professor Peter Childs, who joined the Energy Futures Lab last year as co-director next to me. It is a privilege and a pleasure to be working with Peter. We are very fortunate to benefit from his creative approach and also his experience in design engineering, which he applies to solving energy problems. And Peter, please come along, and everyone, please welcome Peter in giving us the lecture this evening.
Fantastic. Thank you very much indeed, Anna. Thank you for the welcome. Thank you for attending tonight. So I'm really looking forward to talking with you, and you're going to be part of this, about energy supply and energy demand. I see the challenge of energy quite simply. We need it, but perhaps we can think about how much we actually need. So I do have an agenda. I introduced myself this morning as I'm biased, and I hope that's an honest reflection. So I really do have an agenda, and you can see it here. We're going to look at some technologies. We're going to look at the energy mix. I'm going to ask you questions. You're going to have a go, of course. Participation is important. I don't have all of the answers. Maybe I only have a few answers. Tim Green mentioned that we have experienced change over the last 15 years. We haven't seen anything yet, have we, really? Even the UK admits it needs 4 times as much capacity within our networks for electricity alone. And that may be an underestimate. So we'll see how we might get there. Because we're talking about change, it's not sensible to say we're going to change tomorrow. It's not plausible, it's not possible. So road mapping is important. It's something that the Energy Futures Lab has engaged in extensively, and you'll see that in our briefing papers and white papers. So we'll talk about that. Change requires skills, and you've seen a taste of some of the skills necessary in our master's students who've then gone on and in their careers are affecting change at scale. But 50 people or so a year is not enough. We need hundreds of thousands, if not millions worldwide, across all levels in order to effect change in the world of energy. So we will talk about that and then pull it all together. So just a bit of introduction to myself. Academics are good at self-aggrandizement. Let's face it, we like talking about ourselves. So I've had the delight of being professor for about 20 years and have engaged in energy throughout that time in one form or another. Part of my heritage is compressors and industrial gas turbine engines and steam turbines that are still used today. But I've moved on a little bit in terms of turbine size and are now engaged with BladeBUG Ltd, which you've seen outside, perhaps the six-legged robot. Will look at that more in a while. But now looking at turbines on a different scale, the 100-meter or so long turbines that have a very different place in our energy mix in comparison to some of the combined cycle gas turbine kit, which we still need and we still use, but is, in many ways is technology from a former century. You can see some of the things I'm engaged with there. I love teaching. I actually, I do a lot of teaching. I'm engaged in energy courses, fluid dynamics courses, creativity courses, and there's a course I do called Creative Thinking, Tools for Success that over 500,000 people have now been through. So, and I'm looking forward to perhaps millions more on that. So wide-ranging across medicine to design to energy, even into politics. And we will touch upon politics today. No subject really is off today's agenda. We need energy everywhere. So the Energy Futures Lab, we recognise that at Imperial, we recognise that silos are good, getting those in-depth skills. Ladies and gentlemen, at the back, we have 30 seats right at the front, and I really don't mind if you walk down and come and join us at the front, so please do if you wish. But we recognise that all of the disciplines have a role to play. So rather than just concentrating energy perhaps in the chemical engineering department, we have set up the Energy Futures Lab so that it runs across the 20 or so principal units at Imperial. And we have other cross-disciplinary units, which you can see listed here, where silos are great, but they don't give you the whole of the solution that you might need for a systems level or societal level approach. What are we looking at in the Energy Futures Lab? Well, it is extremely broad, from materials to policy to power generating units to the materials we use. I love the focus on materials here at Imperial because it's so easy to come up with concepts. And I've been party to this. We developed technology for chemical looping combustion, but it's only when one of my colleagues did the calculation on how much nickel was required for the pipework that we realised there wasn't enough nickel in the Earth's crust to do the technologies that we were proposing. So a very sensible approach to materials is vital. Which of the chemical engineers in the room don't use iridium in their catalytic approach for something? And you know, there are finite quantities of some of these key materials. So we need to be wise and cautious in this. So you can see the breadth of activities, and indeed the Energy Futures Lab represents about 600 researchers here at Imperial. And then, of course, we collaborate around the world as well. So it is a great delight to be involved in this activity. Taking a wide approach is important. We've all seen these Sustainable Development Goals. And I've just listed the ones which jump out at me in terms of some of our activities. I suspect that none are off the table, but you can see that it's obvious that energy and what we're doing in the Energy Futures Lab is addressing the vast majority of these. So technologies. I said I would give you a go. I don't know whether you're all used to menti.com, but you can see people are grabbing for their phones. So if you have a smartphone, I would love to, and so you can go to menti.com, and then you'll be asked for a code, and you can see the code there, 8650491. Whether you're in the room or you're live or seeing this on live stream, go to that link, and we would like you to answer this question. What technology do you regard as relevant to the UK energy context for a sustainable future? If you're uncomfortable about it being UK limited, well, go wider. Really don't mind. So just enter in whatever comes to your mind or you think is sensible. Nobody's saying it's not working. This is positive so far. Give it another 30 seconds or so, and then I believe that somebody's going to switch over and give us a view of some of the things you're saying. Okay, fantastic. So we can see this. Smart metering. Was that you, Feitang? Wind turbines and heat pumps. Oh, look at this. We got many responses. Pyrolysis. Digitization. And there's all of them. Okay, interesting. Oh, we're going to look down. Nuclear. I love wind turbines. But unless we have maybe 20–25% base load supplied continuously by some technology, there are some people who say that wind turbines mandate the use of nuclear. An interesting proposition and quite provocative. Perhaps there are alternatives, but sometimes when you take a decision, there are consequences associated with that, and you're almost on a directed path towards adoption of a parallel technology as well. Accurate models. I love the modelling teams here at Imperial. I said teams. We don't have one. We seem to have 4 or 5 large groups doing parallel activities in competing. But because this area is so broad and so important, and Imperial is a large university, it's fine to have competing groups even within a single university. No silver bullet, we need everything. You can see some of the technologies listed there, carbon capture. Well, I'm delighted to have your help. We will review this later and see if we're missing something. Perhaps all of these require a bit of attention from the briefing paper team and inserting into the roadmap. Okay, if we can go back to the presentation, please. Thank you very much. There'll be more in a moment. And then I just thought, in case none of you suggested things, I would put up some technologies in advance. I don't know whether these map over well. I've mentioned already some of the rare materials within our planet. Iridium is one of those. If you are doing fuels, for example, or you're trying to change the chemical structure of something, you're bound to need use of exotic materials. That's been recognized, and you can do this in the laboratory, and you can have great success, publish wonderful papers, and show the world new capability. And then somebody says, I want 100 million tons of this. And then you go, well, I'm going to have to do some more research because I need a substitute material for my catalyst. And that is the kind of question that's being addressed by multiple research groups here and elsewhere around the world. And it's vital. Everybody sees the need for change. It's not so easy to get there. And scaling up from laboratory activities towards large-scale activity is important. My ready reckoning of how much hydrogen is produced in the world at the moment, it's about 100 million tons, I believe, per annum. Compare that to the 16 billion tons of hydrocarbons that we use. So those of us talking about a shift between the capability in hydrogen today and where we might want to go, there's this huge gap. Same is true with ammonia, 300 million tons of ammonia and related production per annum or thereabouts. But it's nowhere near that 16 billion tons. How are we going to get there? Well, I'm not going to get there on my own. We're going to need to get there at company level, national level, international level. So all of these topics are actually important. They all represent work, significant work from the 600 or so teams doing activities in energy research here at this university and, of course, elsewhere. Some more technologies. I don't know whether you've had the delight of wandering around Imperial, but one of the really good bits of architecture is the carbon capture infrastructure here at Imperial and the experimentation around that, whereby recognizing that just learning from a lecture slide is not enough. So they've actually built one of the departments, chemical engineering, around their carbon capture technology. And some of these runs are big. You need pipe runs of 20 meters, 30 meters, 40 meters for some of these experiments and capability. So turning the entire building inside out and designing your equipment as part of the building, I think that's a smart move. So there is significant laboratory capability here. And perhaps that's one of the reasons why people come, to actually have a go and do experimental work. 15 years ago, I noted that many universities were going virtual, digital twins, learn everything theoretically. Imperial chose to go the reverse direction, and we have hundreds of laboratories. The workshops have got bigger, not smaller, with greater capacity, and that's an absolute privilege to be involved with. You will see topics here which are not always comfortable to be debated. Downwell processing, sustainable gas. Say in the UK, should we turn our gas supplies off tomorrow? 11 million homes and buildings would not be able to have heating. So we need sensible approaches in order to go forward. And I look forward to questions about that statement, perhaps in 20 minutes or so. I've already telegraphed that I'm engaged with wind power. And there are alternatives to use of petrochemicals. My ready solution is I'd love us to build 70,000 additional wind turbines around the coast of the United Kingdom. I'm being blocked. I've been trying to push forward 5 new wind farms, maybe 15 new wind farms in the English Channel. We only have one. There are all sorts of politicians who run away from me when I get near them because they say they want sustainable power, but when it comes to one near their constituency, perhaps their view is a bit different. 70,000 wind turbines, we could actually do this. It is not implausible. It would create some challenges. Tim will be wincing. How are we going to cope with that when it's not windy for 2 months of the year? August, nightmare for wind because it's sort of a bit of a quiet quiet and non-windy month. And we have had periods of 6 weeks in Europe where there has been very little wind. So you need additional technologies. Bring them on. And perhaps if you're not going to go wind and nuclear, perhaps you're going to go wind and stored hydrogen. So there are options ahead of us. Whichever route we go, it will require vast investment. The UK yesterday, if I recall correctly, improved the strike price for its next auction on, or next large-scale contracts on wind from about 4.5 pence per kilowatt hour to about 7.5 pence per kilowatt hour for offshore wind. A bit more, I think it's 17 pence per kilowatt hour for floating offshore wind. So those entrepreneurs in the room, if you want to tender for some good business, perhaps you should be going for floating offshore wind because you get a lot more money for each kilowatt hour that you're able to sell. But this technology is great. You know, we have shallow waters around the UK, so building offshore wind turbines comparatively easy in comparison to other countries. That's one of the reasons why we've gone ahead. But there are consequences. There's a lot of work on wind. You can't just innocently put up wind turbines. And Sylvain's work, you can see here, dare I pronounce his surname? We talk regularly, but anyway, Sylvain Lezet's work on wind turbine placement, optimizing their positions so that you get the most in-changeable conditions. And it's vital work, and you can get that extra few percent out of your wind farm. And you'll see why that's important in a moment. Putting up a wind turbine, we've been doing this for a long time. And quite a lot of people in operations and maintenance will say, well, the designers did great jobs on designing efficient equipment, but no consideration was put into how they're going to keep that equipment going, how they're going to maintain it and repair it, and give it lifespans of tens of years. But people have begun thinking around this, and you can see some of that thinking in this graphic. And there is a lot of technology. Drones are absolutely brilliant for giving a visual inspection of this type of technology. So you can stop the wind turbine, fly your drone, and get all sorts of important information. We have a lot of remote service vessel technology. This is just cool kit. If you're into your gadgets, this is just wonderful stuff. But this is the enabling technology we need in order to to install this equipment and then keep it running and keep it running at scale. And the equipment keeps on changing. So you may see the autonomous or quasi-autonomous vehicle on the left-hand side of this image. But that is 2023 technology. The world is moving very fast. What are we going to see next in terms of wind turbines? Well, you can see a set of technologies here. Whilst places like the North Sea may just be 20 meters to 60 meters deep, and it's quite convenient to install wind turbines, that type of water is quite rare around the world. So people are looking at floating offshore wind and perhaps tethering wind turbines on all sorts of different platforms. And I'm sure we will see a lot more of this. But I want to talk about more enabling technologies. You'll see a solution for putting up wind turbines in a moment. But I just love this news story that came out a few weeks ago of using the tower itself as part of the crane. And essentially, the crane mechanism crawls up the tower as it produces it. Really smart technology from Enercon. And then these large vessels, and there are only several of these worldwide. ABB have put in this big order for this new vessel. So whilst people like me might say, wouldn't it be great if we had 70,000 wind turbines around the coast of the UK, there are not enough vessels to install this. So whichever was the shipyard who's doing these, perhaps they will be very busy if my vision is taken forward. And then some of you have seen the BladeBUG technologies outside, this hexapod robot. It's actually quite a small robot. You get an idea of the scale on the bottom right-hand image where the BladeBUG is on a wind turbine blade. So it's a hexapod robot, the robot chassis itself, when you go and look at it, you'll realize, oh, the chassis is empty. Deliberately so, because it's really a tool bay. So that you can install any sensor that you might want, any repair equipment, any tool, if you wish. So do go and chat to the BladeBUG team afterwards. A little bit more about it. The wind turbines, they are not just flat surfaces. It's a concave and convex surface. And so we've had to develop a very sophisticated robot in order to articulate over that surface. Anyway, slow-moving video, but you'll get the idea. We have several of these robots at the moment. The company's scaling, and so 2024 looks rather busy for us because we'll probably have to do 15 or 20 robots. And it's just exciting times. Sustainable Energy Futures, the Masters program, have been engaged in this, doing student projects there. If this is your bag, come and chat to us. And what is it actually doing? Well, we're using ultrasonic technology to scan the fiber composite surface in order to examine the integrity. So the drone may say, oh, looks like there's a dodgy patch halfway down the blade. We love drones in BladeBUG because they just drive business our direction. And so the company will then schedule a day to stop the turbine, will then deploy the robot and do a detailed inspection and identify whether there really is a problem. And if there is, then perhaps we can implement a repair as well. So you've got it, the green patch is missing material below the surface, and you're able to pick that up with ultrasonics. Okay, so I've mentioned a passion around both energy supply and energy demand management. There's so much we can do with perhaps tempering our use of energy. And there are many companies involved in that. Large-scale building companies like Barratt's, they have their sort of vastly improved energy efficiency homes using a timber frame construction and very thick sort of insulation, 30 centimetres to 40 centimetres, putting in maybe 50 centimetres of insulation in the roofs. Companies like Chuk doing smart homes where everything is controlled. Really interesting technologies. And then some of the things which maybe you're debating yourselves. When should I get a heat pump? Is it going to be noisy? Is it actually going to save me money? Do I need to do enabling works before I can utilize this type of technology? Well, one of the things I've discovered the painful way in life is nobody likes being told what to do. So if I tell my colleagues, don't buy business class, whoa, there's going to be a big upset. If I say to my family, let's do a heat pump, then loads of questions are going to come out as to how much is it going to cost, what's that going to mean for us, is it going to be noisier, is it going to be warmer? Many challenges. So we need to be extremely sensitive to demand solutions. And academics love to tell other people what to do, and then are we doing it ourselves? You may see me run out through the side door if you ask me difficult questions. One of the other companies I'm principally involved with is Q-Bot. And we have 6 million of these lovely terraced homes in the UK. They are lovely. They actually can be very desirable. I live in Hove, so this is, I've lived in one of these quite recently. Very desirable. They are built with suspended flooring. So you can see that in the cross-section at the bottom. So slightly raised. We need to do that in the UK because of heave. The ground gets wet, dries out with seasons, and also we build on slopes. And so having an elevated home off the floor allows you to cope with gradients and with movement of the ground. So very sensible technology, architecture and engineering, if you wish. But it gives you this cavity on the ground floor. And what we've been doing with the Q-Bot company is developing technologies to spray thermal insulation materials on the underside of your wooden floorboards. And this gives you a 15% to 20% improvement in the heat efficiency of your homes. And the company has done several thousand homes so far. And if you want to turn that into a carbon saving, it's of the order of 15 to 20,000 tonnes so far. But because this accumulates, it should be 100,000 tonnes or so by the end of next year. And again, you'll see the Q-Bot technologies outside. Quite a robust robot. It needs to be for doing this type of work. So I have my next question for you. Audience participation time. Another Menti.com. You know I'm going to show you your answers. So maybe a bit more of an encouragement to have a go. The code, so go to Menti.com and the code is 8650491. And the question is, what does an ideal energy mix or energy solution for the UK look like? And if Peter Childs puts in all wind turbines, I suspect the MSc students in the room might give me 3 out of 10 or 2 out of 10. Now, we are in a room with experts, or many experts. We are in a room with consumers. We are in a room with members of society. So all of us have the right to input into questions like this. You know, this is a community. Not offshore wind, look at that. Nuclear and wind, lots of nuclear, diverse, wood fire and windmill, wind and storage. Geothermal, very interesting. Countries like the UK have significant potential around geothermal. Do we have the 20 to 60 billion to invest in it? Well, these are decisions that countries need to face up face up to and explore. Wind, biomass, gas, hydrogen, nuclear. So some of you are really going for a mix. Interesting. Hydrogen and gravity. Love it. Reliable net zero. A bit of everything. Oh, prosumers. Perhaps people are laughing. Is it the 100% coal that people are laughing at? I remember going through my education and being told that we easily have 1,000 years of coal available just in this country alone, should we choose to use it. But perhaps we need some really good technologies out of chemical engineering to get to exploit that. Okay, thank you very much, ladies and gentlemen. Really good to see that. All right, so an energy mix. How are we going to plan this? Who decides? Should it be competitive? CFD, experts in the room, the mechanical engineers might say computational fluid dynamics. The bioscientists might say citrus fruit disease. The energy experts, it's contracts for difference. And I mentioned the challenge the UK has had over the last 18 months making huge mistake in terms of bid prices in these contracts and tendering. So most commentators just go, we got it wrong in trying to persuade energy companies to supply wind at scale to us, but at too cheap a price. Cheap might sound good for the consumer, but it still needs to be viable. It needs to be viable for all concerned. I've put down the provocation here. Should we take a regional, national, international approach? I'm going to see if I can persuade you of the international approach in a moment. And then just some of the things which you will see that groups around Imperial and other universities are looking at. Whole system models, using smart grids, system integration, energy storage at scale. We're not talking about little car batteries, we're talking about energy storage at the city-wide scale and energy efficiency. And there are big projects. There have been whole conferences associated with the IDLES activity here at Imperial. You can see what IDLES stands for in the slide. It's a large team of 30 or 40 or so researchers focusing on taking forward a low-carbon energy system. And this has worked. Governments have actually listened and implemented the findings from this. And those of you who are interested, you can go onto this website and you'll be able to download significant, insightful materials which are actually helpful rather than just saying we need more work. And then Goran Strabak's work. Check these numbers out. If you take a national approach to a network versus a more of an international approach, the difference in cost. And here I am speaking in a country that decided to explore the conversation around remain or leave the European Union. Regardless of your views about that or my own views, cooperation has its place. And these numbers really tell a powerful story in terms of the difference you might need to tax your communities in order to implement a network that is functional at scale. So I just love this work in terms of what it might mean for a sort of regional versus an integrated approach to supplying chunks of Europe with renewable energy. Okay, getting towards the fast bit of my talk. I think you may get the impression that I think that I'm suggesting change is coming. Well, I don't need to suggest that to you. All of you know that. You will have all lived through substantive changes within your own lives. Let's just talk about the weather for a moment. What's happening? Are we going to get warmer? Perhaps. I've written a very long book on rotating flow. I know one of the people in the audience has this. When you look at atmospheric rotating flows, and I've put out an example of one up from a few weeks ago on this slide, these cyclones are important. Are hurricanes and typhoons good or bad? Perhaps it's a silly question. If we didn't have them, then the equator would get very uncomfortable very quickly. A typical large-scale cyclone, a hurricane, moves vast quantities of energy, the equivalent to 146,000 nuclear bombs equivalent energy poleward. So these large-scale cyclones are vital in our atmospheric mixing, moving energy at scale. So they serve a purpose. But with warming, we can expect more of them in the Pacific and in the Atlantic. large-scale atmospheric movements. So it's going to get windier. Warm air supports more water. Physicists will tell us that, the engineers will tell us that. So warm air, rising plumes of moist air, it will hit cold air at some stage and dump vast quantities of water back on our communities. So it's going to get windier, it's going to get warmer, it's going to get colder, it's going to get wetter. So if any of you are involved in building codes, revisit those building codes, because our buildings need to be able to cope with extreme heat, extreme cold, very high winds, and our foundations are going to be very wet periodically. So just my little challenge to us as a community of practice. Change is coming. Our planet's atmosphere seems to be getting warmer. There are consequences that we just can't ignore. And so building codes is an example where we shouldn't just build with air conditioning and good heating. We've got to build for even more robustness and resilience. Some of us, some of you, are engaged in designing society. This is an options chart. It doesn't matter whether you can read it or not, but it's an options chart. It's a morphological chart. There's an expert in these charts and the software associated with them in the room, allowing you to explore a future society. And these are used at governmental level, think tank level, exploring what kind of society you might want in the future. Doesn't tell you how you're going to get there. For that, you need a roadmap. But I just thought this might be interesting because although this wasn't produced by an energy group, energy is fundamental in so many of the subsystems associated with this. So I've alluded to roadmaps. These are standard in just about every theory of change and every grouping looking at the future. The tech foresighting people, the societal planning people, governments, local governments. You look at where you are now, enablers, so you look at where you are now, well, we know where we are now. You have your ideality. Some of you put your ideality in the response to the Menti survey. And then the distance between those is immense. Well, if you can't figure out how to get there, split it up into little steps. In the energy world, we've been doing this for some time, and you will find that in the white papers, the green papers, the briefing papers associated with groups such as the Energy Futures Lab, but also the large-scale consultancies. So this is actually an encouragement to us. Some of you may be alarmed as to where we are today, but if you know where you want to go, then begin that filling in the roadmap of how we should get there and work within your community of practice and collaborate in order to get that societal change that you might be interested in. Of course, if you're going to make change, the likelihood is that we don't quite have the skills we need or in sufficient quantity. Well, here we are in a university. Lots of great skilled people leaving this university each year. That is great. And there are 2,000 or 3,000 additional universities around the world upskilling people at scale. So this is already happening, but I suspect it's really not enough. Here in the UK, the estimates are that we need of the order of 600 to 700,000 people in the energy sector to effect the transition to net zero. And we're not talking about just graduates with master's degrees from Imperial and UCL and Tsinghua. We need people upskilled across society in the energy sector. And I just thought it was, we're going to need good management. Good management within our companies. We have some CEOs of Britain's largest energy providers here in this room tonight. Just an encouragement to you. we appreciate what you're doing, and please do it well. We have the graduates leaving us each year from Sustainable Energy Futures, and those 600 alumni employing now tens of thousands of people between them. So this long list, just out of ChatGPT, of some of those attributes associated with good management. I think we need to up our game in management, all of us. Okay. It is a delight to be engaged in the Energy Futures Lab. It is cross-disciplinary, interdisciplinary, transdisciplinary, metadisciplinary. And to me, that is important because every time I do one technology, I discover I need something I don't know much about. So collaboration is the key there. I then discover that my intervention may not have been as wise as I originally thought, and we then need a system change. I need a better network. I need my equipment to be somewhere else. I need storage. So all of us are sensible. But I'm just going to challenge us again. Be careful with your silos. Talk and collaborate and think through the impact of your actions. So, to conclude, we have looked at a lot of topics, looked at technologies. We have an abundance of technology. I had the privilege of asking a question to Al Gore some years ago, and I asked him, what innovations does he think the world needs? And I thought it was a great question. And put my hand up from where you are, ask the question. And he just said, we don't need new technologies. We've got loads already. And then he thought a bit, and he then said, oh, yes, we need some really good energy storage. And then he thought again, he kept on listing new technologies that we do actually need. So you don't have to trust me. We do have lots of technologies. Maybe you trust Al Gore. We also need new technologies. But we probably could implement a really good net zero scheme now if we had enough money, or we deployed it, and we had enough skills. So there's another challenge for us. So we probably could do a really good scheme now. I don't know whether it would be the right thing to do. Sometimes progressive change is more comfortable for society than instant change. So I'll leave that one for you to ponder. We are still debating what the right mix of energy technologies and their implementation is. And you could speak to the four different large groups at Imperial looking at this kind of thing, and you'll get slightly different answers, or maybe substantially different answers. So there are decisions to be made around the mix of technologies in order to provide a country like the UK, or indeed any country, with the energy it needs for just about everything we do, from healthcare to entertainment to travel and mobility to heating and cooling our homes. So there is a challenge there around decision making. I've indicated to you that we are living in a changing world. Again, you don't need to trust me for that. Just watch tomorrow's news, perhaps. But even if you do watch tomorrow's news, there will be people like me and people like her and gentleman over there who are effecting large-scale change through innovation. And they're not going to wait. They're just going to go ahead. So whether we like it or not, there are change makers who are intervening, is the right word, in our society and pushing forward new change. So people don't stop, and I don't see any prospect of any of us stopping. I delight in that, actually. new ideas, new capabilities, new ways of doing things. And I think there is hope. We have the technologies for a transition to net zero. We have the capabilities, but we need jolly good management and we need to upskill. Ladies and gentlemen, thank you very much indeed for your attention.
We will allow a couple of burning questions if you have for Peter. We have a couple.
Please state your name. I know your name, but...
Thank you. So my name is Faris Arafat. Yeah, thank you, Professor, for the keynote. Very informative. I think just one question about, you touched on it at the end with the money issue. So I think right now there's this big finance gap, as they call it, where I think $4 trillion per annum is needed to hit the 2050 target. But I think right now is about 1.9 trillion so per annum. So does that worry you, or is that a big problem that we should be looking to solve?
Okay, so it's a great question around who pays and how much is it actually going to cost. So I'm just going to do the heat pump stories. Heat pumps can be really expensive. You can ring up a company and get a quotation, discover that to actually install it, it's going to cost you 50 grand for your home. Or you can go round, get additional quotes and a different story perhaps, and maybe get it down to a third of that cost. So I think we need to be very cautious around and wise in terms of what we pick and how we do it and when we do it. Those of us who can afford it, perhaps we owe it to each other and our society and our community to implement what change we can and do things more efficiently, more effectively. That's just local, that's putting the burden upon the individual. I think there is room for innovation. So something like heat pumps. Currently, the technologies are associated with calling in the contractor to come and do it for you. But I'm saying publicly that there's a space for plug-and-play heat pump technology whereby you install the box outside, the box inside, and some kind of transition coupling. It doesn't have to be that complex. And then you use a smart system and some smart YouTube video telling you what to do and appropriate diagnostics when it doesn't quite work your way. So that plug-and-play technologies for our buildings worldwide for energy efficiency measures. So I think there are 10,000 new enterprise opportunities around plug-and-play energy efficiency improvements based upon existing concepts. But they're not in the market today, or at least not at scale. And then you saw Goran Strabak's work on the networks. Some of the alarm stories about how much it's going to cost us. There are alternatives. And I think taking a more strategic approach can at least halve the cost, if not take it down even further. So I think there's a bit of hope there. You have lots of questions behind you. Oh. I'll let you decide.
Yeah, thank you, Professor Charles. Yes, I would like to quote on your conclusions. We have the technology and we have to be optimistic to achieve net zero. So my question is, are you optimistic to achieve net zero by 2050?
Things can move very quickly. So I am pleased that that strike price for the kilowatt hour bid price from the UK government, they weren't listening and then they did listen and they improved it from 4 pence to just over 7 pence per kilowatt hour. And I think that will mean that some of the large companies, the Ørsteds of the world, the Vattenfalls, perhaps will now step forward and do wind farms at scale again in the United Kingdom. We've seen how fast the Chinese wind farm industry has taken off, companies like Goldwind. huge installations at scale. So, I mean, wind, yeah, I've said a lot about wind. There are drawbacks to wind. Not good if you're a bird, not good if you're a bat. So we need to be wise and careful how we implement these systems. And not everybody, there are politicians on the south coast of the United Kingdom who are blocking wind farms today. My message to them is just stop. Just stop. Allow them to go forward. So I'm optimistic that we can do quite substantive change if we choose.
Hi, my name is Nadal. First of all, thank you for the presentation. It was super fascinating. My background is in theoretical physics, but I'm also a serial entrepreneur. 6 years ago, I started a fintech company. We partnered with Barclays and Lloyds. Now I'm kind of going back to physics and starting a new solar and AI company. And I completely agree in terms of what you said, in terms of the technology exists, it's just not deployed at volume. And what we're trying to create is a prosumer network, which is a consumer who can produce their own energy, but also sell it back to the grid.
Yes. Great.
My big question is, why do you think currently we don't have a system or a way of deploying solar panels and battery at volume, and the user journey in itself is
Love your
terrible?
question. So suppose the four of us owned houses and we were neighbours and we actually liked each other. And we put solar on our homes. All of our roofs are slightly different. The advantage of connecting it up is substantive. But there's a whole set of barriers, as simple as insurance, as simple as is it legal, what happens when one of us moves, so the contracts. So there's a whole set of barriers that exist today for something as simple as community solar solutions. I suspect we will see solar at community scale. Well, there are already patches of it with new builds. So if you're building 300 homes, installing solar and being sensible about how you wire it up so that everybody benefits from the different levels of insolation as a function of time. So I've listed 3 barriers. I believe that one can overcome them. And well, great opportunity for you. Just remind us what the name of your company was again? Zeal. Zeal. Okay, well, if you're interested in a prosumer approach, chat to our friend from Zeal afterwards. I think we've got time for one more question.
One more question, yeah. Let's have Sandra over there.
Hi. Earlier you mentioned the transmission internationally of electricity. How do you see that happening in the worsening geopolitical landscape that we live in?
Okay, so you can tell from my accent, I was born in the United Kingdom, but I actually love my French friends. Okay, so I'm just going to say that. And firstly, they're my friends, but so countries like France and Britain have a history. You just look back just over 200 years. Nevertheless, countries can learn to get along. And in the case of France and Britain, they have been exchanging vast quantities of electricity over the last few decades. So I absolutely believe that countries can be very sensible and deploy the necessary infrastructure to enable the sale of very valuable resource energy from one country to another. So I think it's already happening. In the case of the graph I showed, the graphics I showed from Goran Strabak, we can be even more sensible going forward, and with everybody benefiting, the consumer as well as the providers. Because if the infrastructure is cheaper to install, then perhaps there's higher levels of profit, but the consumer will benefit because it's likely that the price point will go down. So I believe it is possible, but it's classic. We do need to get on with each other. We do need to cooperate and collaborate and discuss. I really encourage you to chat to each other afterwards, because you will get different views upon that. But people like Sandro and Goran and Tim and Anna will give you a different perspective on it. And then, delightfully, the Sustainable Energy Futures Master's students, the innovators of the future, the change makers of the future, they will have their own views, perhaps better than ours.
Peter, with your permission, we will allow Sandro to ask the last question.
Oh, Sandro's going to ask me a really difficult question.
I cannot resist this. Thanks for your very, very interesting talk. And reminds me, when we actually launched the Energy Futures Lab and all that, there was a similar discussion about the technology and this and that, and the mix and all that. So things have moved on, but the discussion is the same. One of the key things that was really evident at that time is that who is Superman and Superwoman who is going to do all of this and understand the systems aspect and all that. And that's where we decided to actually get on and launch the MSc for Sustainable Energy Futures. Now, my question to you, who've just taken off part of the responsibility for that, is that how do you scale it up? Why do we still have only 50 students per year, and we don't have 500 with subsidiaries launched in Kenya, in US, China, wherever? The model works. Why don't we actually put our money where our intentions are? I'm sure you can find some Bezos or others to finance the entire thing.
Thank you, Sandro. Let me, so I've had a challenge. He did not warn me. I've had a challenge from my colleague. It's delightful when you're stitched up by your colleagues. An obvious thing for us to do, and indeed my colleague Anna has proposed that we should be running large-scale seasonal schools with much larger numbers of students, perhaps for a few weeks. So I look forward to these. I say seasonal school. Is it a summer school, winter school, autumn school, outside of term time? And then, of course, the massive online open courses. I think this is something that we could and should be doing so that anybody can engage, and we know that can work. I also think there is something around non-degree level, or we call them, so I absolutely think that upskilling is relevant to us all throughout society. And not everybody can devote 3 years, 4 years of their lives full-time to education. So continuing professional development in all of its forms, and I absolutely think that that's something that organisations like the Energy Futures Lab, Imperial and other universities can engage in. So thank you for your clarion call, Sandro. I think you're right. It's going to be some fun conversations over tea and cake as to how we're going to get there.
Please, let's congratulate Professor Peter Childs. Thank you, Peter. Well done. Okay, thank you all once more for coming today. Of course, we have a lot more still happening outside. We are going to be here until about 9 p.m. So please go and visit the presentations the students have, and also the lightning talks across the room. And of course, if you wish, drinks and small bites down the ground floor.